to cut threads on the lathe, you must become the lathe. If you believe threading to be impossible, you will make it impossible. What the? Wait. Just one moment. Yes, you're looking at one of those cheesy captive nut machinist's puzzles. But bear with me for just a moment here. I am fully aware of the fact that it is 2016, and these sorts of mechanical puzzles, well, probably a bit tacky. I'm hoping to kill two birds with one stone here. First, if I'm to do a thread cutting video, I'm going to need something to cut a thread into. Just figured this might be a little bit more interesting. Second, and probably more important, I've got a major wedding anniversary coming up and I kind of want it to go big. Just to state the obvious, the problem here is that we have a nut captive on a short segment of thread with no apparent way for it to have gotten on there and no way to get it off. If it's done well, that is. Though unfortunately, in this day and age, I'd wager that most people you showed this to probably wouldn't get what the problem is. So this is just a piece of cold roll. It's 20 millimeters, 3/4 of an inch. And I thought we'd use this to cut some threads, maybe in one end, and make another one of these puzzles about here in the middle somewhere. If you'll permit me to add just one thought in defense of the captive nut puzzle, if there's just one person out there who hasn't seen this, if the video helps just one kid, you can certainly make these any size that you'd like. I just went with a larger diameter and a coarser thread. If this is the first time you're cutting threads, I suggest you start with some aluminum. Just make life a little bit easier on yourself. Cold rolled steel is just what I happen to have in this diameter. Just 1 minute. Stop the music. We need to have a little heart-to-heart. If you're not really into cutting threads, this might not be the most exciting video in the world for you. Sure, you'll miss a ton of great jokes and mind-blowing special effects, but no hard feelings. I look forward to seeing you on my next video. Wreck your YouTube video before it even starts in one easy step. If thread cutting is what gets you out of bed in the morning, well, you've come to the right place. I'm not going to go into excruciating detail on every step of the process. I will go through it basically step by step, but what I'd like to concentrate on, and what I think is usually the most challenging when you're first trying to learn to cut threads, is the part where you're actually cutting them, like the motions. Which knob gets turned when and why, which lever you throw. All that other information that of course is very important, is important once you sort of already know what you're doing, once you're already very comfortable with your machine. Let's just talk about what we're trying to do here. We're starting out with some chunk of material, and with some voodoo on the lathe, we want to turn it into something like this, right? We want to cut a thread onto it. Now this isn't the thread we'll be cutting, but it's big and easier to see. This happens to be a metric thread, M36x4. We'll get into that in a second, but it doesn't really matter. As long as you know what thread you want to cut, you'll be fine. I'm going to be cutting metric threads for two reasons. First, I think the nomenclature is a little bit easier to understand for someone who's maybe just getting into this. And second, my lathe's already set to cut up metric. Alright, so in this case, the OD is 36, and the pitch, or the spacing between the threads, is 4 millimeters. Again, that makes it a 36x4. In English, or imperial, this is about almost 1.5 inches, and it turns out to be about 6.5 TPI. That's threads per inch. So in metric, they give you the spacing, it's 4 millimeters between each thread, and in English, it's a thread count over a certain distance, that distance being 1 inch. So if you were to cut off 1 inch of this, you'd have 6.5 wraps of thread going around it. The other important bit for our purposes is the thread form itself, the shape of the thread. This happens to be a standard 60-degree V thread, but with some minor annoyances, that's really not relevant. It just sort of dictates the shape of your tool. You could be cutting V threads, Acme threads, square threads, buttress threads, hearts and stars. It doesn't really matter. Just like anything else in life, threads can get as complicated as you want them to get. Have a look at the threading section in the Machinery's Handbook, and you'll find all sorts of information on tolerances and fits and standardized radii, all sorts of stuff that's meant to ensure that the part you make fits where it's expected to fit. All right, let's get to it. I'm not paying you to stand around and talk all day. So the thread I want to cut is an M18 by 2.5. That means it's 18 millimeters in diameter and 2.5 millimeters between the threads. You'd measure the diameter with calipers or a micrometer depending on what you're trying to do, and use a thread gauge to measure the threads. You just find the one that fits and you have your winner. So we've got to set up the lathe to cut 2.5 millimeter pitch threads. We're trying to cut a spiral, and a consistent spiral at that. And setting up the lathe to cut that pitch of thread means that for every one revolution of the chuck, the tool is going to move 2.5 millimeters in this case. So if I turn this one time, that tool will have moved 2.5 millimeters. If I move it 10 times, that tool should have moved 25 millimeters. Now every lathe is different. It's special. It's like snowflakes. It's going to be up to you to figure out how to set up your lathe for the specific thread that you'd like to cut. I'm going to take the back cover off of mine and I'll show you what's going on. Make sure you cut the power before you take your lathe apart. Alright, so at first blush this might look complicated, but it really isn't. There's not too much to it. Ignore that thing hanging on the wall there. That's an old vice mount English wheel I made 1,000 years ago. So this particular lathe happens to use a combination of change gears and a quick change threading gearbox. If you don't have a thread cutting gearbox, you'll probably have some stack of gears somewhere that, depending how you put them together in the back of your lathe, sets the lathe up for some thread pitch. In the base of the machine, in the bottom, there's a motor. Powers the whole works. There are a few belts that come up out of there and connect to the drive shaft that go into the headstock. That powers the chuck, or the spindle. That's completely separate from the power feed and threading gearbox. Out of the headstock, below the spindle, there's another power output. It's sort of the same thing as the spindle or the chuck on the other side, just out the wrong end here. And here's where we start to connect the hip bone to the leg bone, and the leg bone to the shin bone, and the shin bone to the foot bone, until we get to the saddle. And of course the tool. So we've got the power connected to the feed box, the threading box. Once power gets into that quick change gearbox, you can pick where it comes out of that gearbox on the right hand side. You either power the lead screw at the top there, or you power the feed shaft right below it. The lead screw is for cutting threads, and the shaft just sends power for turning and facing. And that there is where it connects to the saddle. In this case it's meeting the thread dial first, but we'll get to that a little bit later. Now what happens in the saddle stays in the saddle. Now what happens in the saddle is very interesting, but we won't get into that here. I just wanted to highlight the fact that since we have two inputs into the saddle, on the left hand side there, we have two controls in the front to decide which one of those we want to use. On this lathe, this is the surface speeds for turning and facing, and this is the half nut that engages the lead screw. And it's this lever here that leads to most of the anxiety in thread cutting. When you throw this lever, it pretty much turns your lathe into a runaway train. Never coming back. Wrong way on a one-way. So on my particular lathe, to set the 2.5 millimeter pitch that I want to cut, I just read the positions of all the levers off the threading chart. This will more than likely be different on your machine, but just check your manual. This is the lathe running at its slowest speed. In this case, it's about 50 RPM. The half nuts are not engaged, so the carriage and the tool aren't moving. When I engage that, the lead screw is going to start to pull the tool and the carriage towards the headstock at the rate that we just set up in the gearbox. You can cut threads at any speed that you like, any speed you're comfortable with, but I recommend starting off as slow as possible, just for safety's sake. Though unfortunately, threads tend to turn out nicer the faster you cut them. It's just like when you're turning. If you're not going sort of at the right speed, you could get some weird surface finishes. But you can thread by hand. You don't even have to turn the lathe on. It's just, you're going to kill yourself dragging the carriage through the whole drivetrain of the lathe. But turning the chuck by hand sometimes is useful when you're threading up to a shoulder and you want to get in really close. You can do those last half or quarter of a turn by hand. Since I want to cut a 60-degree V thread, I've got a 60-degree V ground into the tip of the tool. You can make these in any shape and size you like, as long as that shape is a 60-degree V and fits into the thread you're trying to cut. I've got a large one and a small one. You can actually even see the small one needs some sharpening. But generally you'll want to use the biggest tool that fits in the work. It's just more rigid. The tips are usually offset a bit to the left instead of being right on center, the V I mean. That's just to help you get a little bit closer to potentially a shoulder or, to the chuck basically. But that V could point in any direction. It might even be bent 90 degrees for internal threading. The V would come off one side instead of the front. Now, I just happen to do mine on a surface grinder. Smoke them if you got them. But a couple of licks on the bench grinder would certainly do the job. Now, before I was living the high life, I had made one of these sharpening sleds. It's just a piece of flat stock with a bit of an overhang that lets it slide on the table rest. It has a few angles cut into it for different tools. The tool really just butts against it, sets that angle, and then you just grind it down till you get a point. Now, certainly you could just throw caution to the wind and grind this freehand. Maybe strike some marker lines, and when you start to get close, come in with one of these thread gauges, or these fishtail gauges, and sneak up on that 60-degree angle. Now, if you're just starting out and you'd rather not deal with sharpening tools, you can buy high-speed steel threading tools already shaped for you, and then as you use them, just keep them sharp. All right, let's do this. Before I start to do any thread cutting, I need to get this down to the nominal diameter of the thread that I need to cut, 18 millimeters. So I'm going to take 2 millimeters off the diameter before I do anything else. Although the lathe is set up to cut 2.5 millimeter pitch, the lead screw isn't even engaged yet. I'm going to be using the power feeds to take this down. Now, there is a tolerance on that nominal dimension. If the crests I get after cutting the threads end up being exactly nominal, 18 millimeters in this case, and the nut that threads onto here is also 18 nominal, it won't actually thread on because they're the same size. So this typically wants to be a few thou undersize. I usually don't worry about it here. I just kind of knock the sharp edges off with a file once the threads are cut. But don't ignore that major diameter. It's very easy to get to the point where you think your threads are finished, you've measured them, they look like the right size, you try to put the nut on, it doesn't fit, so you keep taking threading passes. What'll happen is you'll eventually knock down that major diameter, the nut will fit, but your threads will be sloppy because the material was supposed to come off the crests, the top, not out of the whole thread. But one step at a time here. I should also note we're going to be doing this the old-fashioned way, no time travel. I got the electric bill for last month. You can see June saw a bit of a spike in my energy consumption. And that did not go over very well with the wife. The portion I want to thread is now down to 18 millimeters. I also cut a chamfer in the leading edge and a bit of a gutter here in the back. The convenience of that, if you're allowed to have one for the part that you're making, is that it gives you a space for your threading tool to essentially run into. It gives you an area to retract the tool without potentially nicking the rest of the part. So as you're making the cut, you get to a point where your tool leaves the steel and you have a chance to retract it. Typically, you'd want to make this little gutter as short as possible, but the width of that really depends on how your cat-like reflexes are, or if someone spelled it out on the print. But if I were to be completely honest, if you're completely new to this thread cutting business, my recommendation would be to ignore almost everything of what I just did. Just throw some steel in the lathe and start cutting some threads on it. Don't worry about dimensions or if a nut's going to fit. Just get into the swing of cutting those threads and getting comfortable with the machine. There's so much stuff you'll pick up about the specific quirks, what the finish looks like, what speed you're comfortable cutting at, and all of these details like chamfers and gutters will slowly become evident as you start to run into the issues that first caused people to invent such things. All right, so finally everything is set up for me to mess these threads up and ruin my day. The only thing left to cover is this whole 29.5-degree business. But in order to do that, we're going to have to take a closer look at the threading tool itself. Setting the top slide over half of the thread angle isn't strictly necessary. In fact, I only ever really do it for large threads in steel. For small threads and in softer materials, I don't even bother to swing the top slide. Unless I start to get issues with the finish or chatter, in which case I will. Thread cutting tools are form tools. And what that means is that the form of the tool is sort of imparted onto the work. That's why that 60-degree angle is so critical. If you made that 59, you're going to end up cutting 59-degree threads. Here are another couple of form tools that I have. These cut an inside and an outside radius respectively. So this dull one, for example, gets pushed into the work. It removes all of the material in this shape, and you remove it, leaving this shape behind on the work. The form of the tool is transferred into the work. This 60-degree V form results in a 60-degree V thread. When you first start out, just the tip is cutting, and it's smooth sailing. Go a little bit deeper, life is still looking good. And this is why for small threads or soft material, it doesn't matter where your top slide is pointing. When you get to a certain depth though, you have a lot more, that's exaggerated, you have a lot more of that cutting edge in contact, and chatter starts to rear its ugly head. Now at this point you may be thinking to yourself, this old Tony, Isn't there any way to reduce that contact pressure and still end up with a good V-thread? Well, that's an excellent question. Permit me to resort to some visual aids. Alright, so this is the round stock we want to cut some threads into. We'll hold it in the trusty 3-jaw. Let me just chamfer the ends here and cut in a groove for the threads to spill into. So I've got 2 threads sketched in here. You probably can't see them, but doesn't matter. The first we're going to try to cut by basically plunging the tool. So what you're going to be looking at here is multiple passes until we get to full thread depth. Alright, let's take a look at what those chips look like. The tool has taken a chip on both cutting edges. Now, although this looks like it turned out pretty good in cardboard, in metal, what will happen is that that chip load will sort of switch up between the 2 cutting edges very quickly. You get into this chatter. Now again, don't take this literal. You don't move straight in with the tool. This would be a long string, like a long curl, a long chip all the way along the length of the screw. But what do I look like, George Lucas here? Alright, so this time, instead of moving straight in, let's swing the top slide over 30 degrees. We're still keeping our tool perpendicular to the work, but it's now going to be moving at 30 degrees. Alright, so I hope that illustrates the point. Moving the top slide and the tool at 30 degrees, basically half the angle that the tool is sharpened to, half the angle of the thread, results in cutting on only one edge of the tool. So that was 0, this was 30. And I'm sure you can guess what happens at angles between those extents. As you start to move away from 0 to 30, one side gradually gets thicker while the other side slowly disappears. One edge of the cutting tool is cutting more and more, and the other edge is cutting less and less, until you get to 30 degrees and you have one cutting edge not cutting at all. So moving in at some angle gets us less tool pressure, less cutting pressure, and effectively the same end result. Well, with the better surface finish, that is. Now you wouldn't want to cut exactly at 30 degrees. I mean, first of all, it's difficult to even set the top slide up to exactly 30 degrees. Again, it's still a form tool. We want to impart the form of this tool on the workpiece. So you set the top slide not to 30, but 29.5. Now that I went to all that trouble, it's starting to feel like it probably was not necessary. Like I could have probably just talked through it without all the arts and crafts. But anyway, that's where the 29.5 degrees comes from. That's for a 60-degree thread. In this case, since I'm cutting a metric thread, it's 60 degrees Celsius. If you're cutting an English thread, be sure to do it in Fahrenheit. Keep in mind now that's for 60-degree threads. If you're doing an Acme thread, a 20-degree included angle, or you're doing a 55-degree included angle, like a Whitworth thread, a 30-degree, whatever your thread is, your top slide would be set to slightly less than half of that. Let's head back to the lathe. You can ignore the fact that I'm using a collet chuck. It just what happened to be on the lathe when I started making this video. You could do this in a collet chuck, a 3-jaw, 4-jaw, between centers. Weld the work right into your spindle if that's what you got to do. Whatever it takes, man. Whatever it takes. Same goes for the live center. Use end support at your own discretion. In this case, I got the threads far out of the chuck that it makes sense to use one. I just happen to have it this far out, so I can get around it with the camera. Now if you ground the tip of the tool using some kind of a jig or a fixture, you can just bump up the side of your tool up against your chuck and you'll know that your V is centered to the work. If you ground it freehand or you're not sure, you can use one of these fishtail gauges. Put that on your tool and use that to square it up against the work. Let's pick up that surface and zero the dials out. Make sure to zero out both your dials, cross slide and the top slide. Move the tool off the work and using your top slide, give it just a couple of thou depth of cut for the first pass. Top slide will be setting how deep the tool is. Your cross slide is always going to stay at 0. We'll get into that in a minute. If you like, you can blue up the work just to make it a little bit easier to see. At this point, engage the half nuts to take the first pass, what's usually called a scratch pass, and is used just to verify that the machine is set up the way we think it is. Stop the lathe when you get into the thread gutter. Now in my case, I haven't released the half nuts, they're still engaged, I only stopped the lathe. This lathe has a brake, so I can stop it pretty quickly. If you don't have a brake, when you get to that thread gutter, you'll want to stop the lathe and retract the tool pretty much at the same time. And that retraction is done with the cross slide. The top slide is still dialed into that couple of thou we used for the scratch pass. Check the scratch pass with your thread gauge to make sure everything is going as planned. Now this is the part where things potentially get a little bit sticky. We need to get the tool back to point A and take really our first cut. Now you can't move the carriage because it's locked to the lead screw via the half nuts. That's the backlash that's in my lathe. At this point we've got two options: decisions, a fork in the road, consequences. We can either release the hounds, we can either release the half nuts and then just hand wheel it back to the beginning, or we can reverse the lathe and run it backwards under power to the start of the thread. Now we said the half nuts lock the carriage to the lead screw. If we release the half nut, we'll be able to hand widen back to the beginning of the thread, but we won't really know where to lock those half nuts back on. We won't know if we're locking in the same position that they are now, and we risk going out of sync with the threads. You basically may end up not cutting in the same spot that you made your scratch pass in. And if you do that enough times, you won't have a thread left to show your friends. Now, of course, the solution to that problem is the thread dial. The thread dial is a visual indication of where the lead screw is in its rotation, but we'll get into that in a minute. What I'm going to do, and what I suggest you do on your first few threads, is reverse the direction of the motor. The half nuts are still locked, and now when I power the lathe up, the motor, the spindle, and the lead screw will spin the opposite direction, running my saddle back to the beginning. In the interest of full disclosure, and to keep from looking like a knucklehead by anybody out there that's familiar with how these Colchester lathes work, I don't really have two options here. My only option is to reverse the lathe. For this particular lathe, if I want to cut metric threads, I can't release the half nuts. Now even if I could, which I can't, totally not bitter about that, I'd still recommend you cut your first threads by reversing the motor. And now I'll just run the lathe back. But if you can't reverse it, you can always turn it back by hand. Now, I did tell you to do these in low gear, so I don't envy you. Go back a little bit further than the beginning of your thread. That way, if there's any backlash in your machine, it'll get taken up before you're actually in the cut. Now we just need to reposition the tool and we can take pass 2. Be sure to use your cross slide to get back to that starting point, not your top slide. The cross slide always stays at 0. Use your cross slide to get the tool the heck out of the way. When you come back to the beginning, use it to get the heck back in the way. And your top slide adds more depth of cut, cuts the thread deeper. The top slide, of course, is still at that 2 thou we set for the scratch pass. I'm just going to add about 5 or 6 for the next cut. At this point, you might want to just add some oil and hit start on your game controller. Stop the lathe and back out at the end, flip the motor direction, and head back home. We'll stop again a little bit past the beginning, go back to 0 on our cross slide, advance the depth of cut another 5 or 7 or 8 or 10 thou, it depends on your lathe. Make sure the motor is back in the forward direction, take it for another ride. So that's pretty much it. You do that about a dozen times. You'd want to keep an eye on your progress by measuring the thread. There are formulas that tell you how much you should move in terms of a depth of cut, but as you get close you'll want to start checking with either a thread measuring micrometer or some wires. But if you're just starting off, I wouldn't even worry about that. Just cut threads till it looks like a thread. So let's back up a minute and talk about option 2, using a thread dial. I'm not certain if my wife could actually identify which one of these machines is the lathe. I don't think that'd stop her from giving me a hard time for not having cleaned it up before I made a video. If your lathe has a threading dial and you want to use it for threading, make sure it's engaged. Typically you can just swing these in and out of mesh if and when you need to use them. When the dial is engaged, it'll turn with your lead screw. I don't know if you can read it. I've got numbered divisions 1 through 4, and I've got divisions between those with no numbers. Mine also has a little rivet here as sort of the timing mark. There's not much to the thread dial. It really just keeps track of the rotational position of the lead screw. Being able to engage and release the half nuts really has 2 big advantages. The first one is you don't have to wait for your lathe to push your carriage all the way back to the start of the thread. If you're cutting slow and it's a long thread, well, it can get tedious waiting for it to get back. If you release the nuts, you can just hand wheel back to the start. When you get there, you just take a look at your dial, wait for your number or your line to come around, throw the lever, and that'll engage the carriage back onto the lead screw at the same position you left off. So it'll maintain the timing of your thread. Second, it allows you to stop the tool much faster when you get to the end of the thread. Instead of stopping the lathe with the motor, you just disengage the carriage. So it will stop, the tool will stop, but the lathe is still running. Most of the time that means you can get the tool out of there faster because you're not waiting for the whole inertia of the machine to sort of slow down for you to be able to reverse and go the other way. If you're just starting out with a thread dial, I recommend just picking a line and sticking with that on every pass of your cut. And by that I just mean remember the line that you threw your half nut lever on and just use that same line for every pass of the thread. The downside is you have to wait for your particular line to come around. And although the first time it's not that bad, the second and subsequent times essentially take forever. You can engage the lever on 4 or all of those lines depending on whether your thread is even or odd number of pitch. You can check your manual if you want to know more or just Google it. But for your first time out, maybe it's worth just picking one line and sticking to it. So I think that more or less covers it for thread cutting on the lathe. I mean, at least the big picture. In practice, there's really no end to the problems you might run into with thread cutting. You might have to do left-hand internal Acme threads, which might take a little practice. But once you get comfortable with the basics, cutting threads is easy, is what everybody that already knows how to cut threads will tell you. But again, my suggestion, don't worry about all of the dimensions and getting exactly the right tool ground, the perfect angle, the perfect surface finish. Just chuck some stock up in your lathe and start to cut helixes. As you grow familiar with that, and your lathe in particular, you can start digging a little bit deeper into the details. Oh, I almost forgot about the puzzle. Now, I'm sorry you had to find out this way, but there's no magic involved. It's 2 pieces held together by a smaller internal thread before you even cut the external. Start off with 2 pieces you want to use to make the puzzle, a little bit larger than the thread you want to cut, of course, so you have something to capture the nut with. Then face, drill, and tap each one of those parts. Be sure to face them both off as smooth as possible. We'll want that joint to disappear once we thread it. Then connect the 2 with a section of small thread or a long set screw. And with the ends supported should you need it, just mark out and rough down your nominal diameter. Cut your threads in, take it apart, thread the nut on. The only difference with this thread is you don't have an end to come off with the tool. So you're going to have to feed in, cut the thread, feed out, repeat that until the nut fits. When you put it back together, put in some Loctite so this thing doesn't simply screw apart. Polish it up a bit and take it down to the bar on Friday night. Show it around to your friends. Best Friday night ever.